Yellowstone National Park hosts a potentially catastrophic threat rated at Category 8, presenting a significant danger to the United States. The park's alert system has detected a dome-shaped uplift, indicating magma movement beneath the surface. Spanning a vast 2.2 million acres across 3 western United States states, this park is home to a supervolcano. Geological experts are deeply concerned about the escalating activity in Yellowstone, one of the most active geological regions on Earth. After an astonishing 70,000 years of dormancy, this colossal entity in the western U.S. is showing minor movements over time. If it fully reawakens, the eruption's scale and impact could be unprecedented. Yellowstone National Park, extending across Wyoming, Idaho, and Montana, holds this supervolcano. Situated in northwest Wyoming, a significant part of Yellowstone houses this supervolcano. Below its surface lies magma, or molten rock, forming a magma chamber positioned 6 to 10 kilometers beneath the park, causing ground elevation and expansion. Although the magma solidifies over the years, the ground remains elevated. Monitoring since 1923 reveals a steady ascent, with a 25-centimeter rise in the ground. Concerns are growing that an eruption might occur soon. The potential magnitude of such an eruption is a source of worry for all, both now and in the future. Subterranean activities have heightened concerns about a major eruption. The volcano has expanded rapidly in the last decade, resulting in increased devastation. Yellowstone experiences between 1,000 to 3,000 earthquakes annually, most of them imperceptible due to their low magnitudes. These earthquakes offer crucial insights to scientists regarding magma replenishment. A noticeable increase in quantity and intensity could indicate a substantial influx of magma into the reservoir. Scientists emphasize that the activity in the magma chamber is not an immediate hazard. However, the comprehensive study and observation of Yellowstone are lacking, making predictions challenging for geologists. The volcano's ancient history has been instrumental in educating researchers. Yellowstone's geology reveals 3 significant eruptions in the last 2.1 million years, estimated to occur approximately every 600,000 to 800,000 years. The last major eruption transpired approximately 640,000 years ago, affecting the park and vast surrounding areas. This valley represents a caldera, akin to the Yellowstone supervolcano. An earthquake could create a caldera in Yellowstone, posing a natural hazard. Scientists argue that the last Yellowstone explosion was 1,000 times more powerful than the 1980 Mount St. Helens eruption, which claimed 56 lives and caused extensive damage. The Yellowstone supervolcano erupted thousands of years ago, spewing ash, molten rock, and poisonous gases, casting darkness over a significant portion of the land. Following the explosion, pyroclastic flows moved menacingly, devastating everything in their path. Magma also erupted, scorching kilometers of the countryside. The Yellowstone caldera still bears the scars of this colossal explosion, covering a vast area. The lava field is blanketed in volcanic ash. The caldera, along with its vibrant geysers and bubbling pools, transforms this 3,472 square mile park into a natural spectacle. The intriguing occurrences, such as Norris Geyser Basin and over 500 hot springs, are indicators of volcanic events. The Norris Geyser Basin, boasting more than 500 hot springs, stands out. Northwest of the caldera, these geysers and pools undergo continuous changes, signifying volcanic activity. Over the past 2 decades, this region has experienced significant alterations. The basin, larger than Chicago, has encountered unpredictable inflation and deflation. Understanding these shifts in a highly active volcanic area like Yellowstone poses a significant challenge. Scientists have examined satellite-based radar and GPS data from the Norris Geyser Basin, dating back decades, modeling subterranean changes based on surface variations. They identified a mass of magma beneath the area in the late 1990s, Confined magma fluids started to effervesce and traverse through a complex network of rocks above. These fluids encountered obstructions, generating immense pressure that lifted the land. However, when they found alternate paths, the pressure diminished, causing the ground to deflate and sink. In March 2014, a 4.9 magnitude earthquake marked the end of the uplift in the Norris Geyser Basin, disrupting the tranquility. Subsequently, the ground gradually rose and fell, reaching a level 5 inches higher than in 2000 by early 2019. Stable magmatic intrusion caused this elevation from 1996 to 2004. The magma chamber's pressure dropped as dissolved fluids escaped and cooled, akin to a deflating balloon. From 2005 to 2013, deflation caused a lowering of the ground. Trapped fluids within rock layers for years were a contributing factor, resulting in an unexpected ground rise. Describing this magmatism has been a challenge for scientists. Michael Poland, the director of the Yellowstone Volcano Observatory, believes the new model is promising, although concrete evidence is scarce. Other potential sources of fluid could include recent heavy rainfall and emerging magma pockets. Residents living in proximity to the magma body occasionally witness environmental changes. This complexity underscores the need for more information and research. The study team suspects that magma-derived fluids near Norris Geyser Basin might have caused geothermal eruptions, forming craters thousands of years ago. In a geological pressure cooker, hot water boils into steam if the rock fractures. Unfortunately, predicting these eruptions is exceedingly difficult due to the intricate network of subsurface tunnels and pathways within the rock, which can undergo various changes triggering an explosion. Future eruptions remain unpredictable. The study team doesn't advocate for closing the region to visitors, but they do question whether the sudden rise in activity and outbursts of Steamboat Geyser is linked to the buildup of magmatic fluids. The movement cycles of the basin may have intensified activity in the 1960s and early 1980s. The peculiar behavior of Steamboat Geyser remains uncertain. The increased activity of Steamboat Geyser and magma intrusion align, though the cause remains unknown. Scientists are eager to study water chemistry for further insights. Nonetheless, scientists' ability to explain these remarkable shifts underscores the wealth of information gathered and advancements in modern scientific methods. This concludes today's discussion. We welcome your thoughts on this incredible discovery. Feel free to share in the comments section and consider subscribing for regular updates.